Earth spins at more than 1,600 kilometers per hour, yet nothing ever slows it to a stop. Why? What invisible force keeps this massive planet rotating non-stop, day after day, for more than 4.5 billion years? And could it ever actually stop? Today, we're diving straight into the surprising truth behind Earth's unstoppable spin, where it began, what keeps it moving, and the remarkable factors that are slowly changing it right now. By the end of this video, you'll understand the hidden physics behind every sunrise and why Earth's rotation is one of the most important motions in the entire solar system. Earth's rotation didn't start after the planet formed, it started before Earth even existed. Imagine a giant cloud of gas and dust swirling through space. This solar nebula was already spinning due to a fundamental rule of nature, angular momentum. As gravity pulled the cloud inward, it spun faster like an ice skater pulling in their arms. This rotating disk eventually gave birth to the sun, the planets, and all the debris in between, including the early Earth. When tiny particles collided and clumped together to form planetesimals, they inherited the rotation of the disk. By the time Earth grew large enough to be called a planet, it was already spinning rapidly. And then came one of the biggest events in planetary history. An object the size of Mars likely slammed into early Earth. That colossal impact didn't stop the rotation. It reshaped it, altering the speed and tilt and ejecting material that later became the Moon. The key idea here is simple. Earth spins today because the early solar system was spinning, and angular momentum must be conserved. Once a massive body starts rotating in the vacuum of space, there's nothing substantial to take that momentum away. Transition. But inheriting a spin is one thing, keeping it going for billions of years is something else entirely. You might wonder, why doesn't Earth slow down the way a spinning top does? The answer lies in the environment. A spinning top stops because air resistance and friction with the floor gradually drain its energy. But Earth isn't sitting on a surface, and space is nearly a perfect vacuum. There is no air, no friction, no resistance. Nothing is pushing against Earth's motion. Here's where Newton's first law comes in. An object in motion stays in motion unless acted upon by an external force. For Earth, no such force exists powerful enough to stop its rotation. Even factors people assume might affect it, like the sun's radiation, the solar wind, or magnetic fields, barely make a measurable impact. They're simply too weak. Earth's rotation is also stabilized by its internal mass distribution. The heavy iron core and dense mantle act like a giant flywheel, helping maintain a smooth, consistent spin. Even massive events like volcanic eruptions or shifting tectonic plates only change the rotation by milliseconds. In short, Earth keeps spinning because nothing is slowing it, and because angular momentum naturally resists change. Transition. But while nothing is stopping Earth, something is gradually slowing it down, and that's where the story becomes even more interesting. Although Earth isn't stopping anytime soon, its rotation is slowly changing, and the culprit is the Moon. Through a phenomenon called tidal friction, the Moon's gravity pulls on Earth's oceans, creating tides that slightly drag against the planet's rotation. Over millions of years, this tugging acts like a gentle brake. The effect is tiny, but constant. Fossil corals reveal that 600 million years ago, a day was only 22 hours long. Go back even further, an early Earth may have spun once every 6 hours. Earth's rotation also shifts due to changes in how mass is distributed across the planet. When glaciers melt, water moves toward the equator, slightly slowing rotation. Earthquakes can do the opposite, redistributing mass in a way that slightly speeds things up. Even strong winds and ocean currents create micro-adjustments measured in fractions of milliseconds. And what's the future? Earth's days will continue getting longer. In the far future, hundreds of millions of years from now, Earth and the Moon could eventually reach a state of tidal locking, where one always shows the same face to the other. It won't happen in our lifetime, but it reveals just how dynamic Earth's rotation really is. Earth's endless spin isn't magic, it's a story written at the birth of the solar system. The collapsing nebula gave our planet its first push, and in the near-frictionless environment of space, that motion never had a reason to stop. Only the Moon's steady gravitational pull gently slows the rotation, stretching our days little by little. Understanding this motion matters because Earth's spin shapes nearly everything: daylight, climate, seasons, stability, and even life itself. If you enjoyed this deep dive, hit like, drop a comment, and subscribe for more exciting space exploration stories.